In this and next lecture, we will talk about the reverse logistics framework. Reverse logistics has been stretching out worldwide, involving all the layers of supply chains in various industry sectors. While some actors in the chain have been forced to take products back, others have proactively done so, attracted by the value in used products. One way or the other, reverse logistics has become a key competence in modern supply chains. The border between forward logistics from raw materials to end user and reverse logistics from end user to recovery or to a new user is not strictly defined, as one can wonder about what raw materials are or who the end user is in modern supply chains. For instance, used recovered glass is a substantial input for new production of glass. A holistic view on supply chains combining both forward and reverse logistics is embraced by the closed-loop supply chain concept. Recovery practices are framed within the supply chain, and the encircling aspect of the process as a whole is therefore stressed, having either a physical closed loop to the original user or a functional closed loop to the original functionality. Thinking in terms of closed-loop supply chains emphasizes the importance of coordinating the forward with the reverse streams. Actually, whenever both forward and reverse flows are involved, coordination has to be minded. This happens either in closed or open loops. The latter refers to when neither the original user nor original functionality are in the reverse logistics process. Let's now examine the fundamentals of reverse logistics by analyzing the topic from four essential viewpoints: why, what, how, and who. These types of characteristics are relevant to characterize reverse logistics. Why are things returned? We go over the driving forces behind companies and institutions to become active in reverse logistics, why drivers, receiver, and the reasons for reverse flows, return reasons, or why reasons the sender. What is being returned? We describe product characteristics which make recovery attractive or compulsory and give examples based on real cases, products, and materials. How reverse logistics works in practice? We give a list of processes carried out in reverse logistics systems, and we focus on how value is recovered in the reverse chain. Who is executing reverse logistics activities? We go over the actors and their roles in implementing reverse logistics. Now let's start with why drivers, receiver, driving forces behind the reverse logistics. In the literature of reverse logistics, many authors have pointed out driving factors like economics, environmental laws, and the environmental consciousness of consumers. Generally, one can say that companies do get involved with reverse logistics, either because they can profit from it, or because they have to, or because they feel socially motivated to do it. Accordingly, we categorize the driving forces under three main headings: economics, legislation, and corporate responsibility. Economics. A reverse logistics program can bring direct gains to companies from dwindling on the use of raw materials, from adding value with recovery, or from reducing disposal costs. Independents have also gone into the area because of the financial opportunities offered in the dispersed market of superfluous or discarded goods and materials. Even with no clear or immediate expected profit, an organization can get more involved with reverse logistics because of marketing, competition, and strategic issues from which are expected indirect gains. The economic driver embraces the following direct and indirect gains. Direct gains: input materials, cost reduction, and value-added recovery. Indirect gains: anticipating impeding legislation, market protection, green image, and improved customer-supplier relations. Legislation refers here to any jurisdiction indicated that a company should recover its products or accept them back. In many countries, home shoppers are legally entitled of returning the ordered merchandise. Furthermore, and especially in Europe, there has been an increase of environmentally related legislation, like on recycling quotas, packaging regulation, and manufacturing take-back responsibility. The automobile industry and industries of electrical and electronic equipment are under special legal pressure. Sometimes companies participate voluntarily in covenants either to deal with or get prepared for legislation. Corporate responsibility concerns a set of values or principles that in this case impel a company or an organization to become responsibly engaged with reverse logistics. Nowadays, many firms have extensive programs on corporate social responsibility, where both social and environmental issues become the priorities. One should notice that these are not mutually exclusive motivations, and in reality it is sometimes hard to set the boundary. In many countries, customers have the right to return products purchased via a distant seller as mail order companies or e-commerce. Thus, these companies are legally obliged to give the customer the opportunity to send back the merchandise. At the same time, this opportunity is also perceived as a form to attract customers, bringing potential benefits to the company. Why reasons sender return reasons for reverse logistics? Roughly speaking, products are returned or discarded because either they do not function anymore properly or because they or their function are no longer needed. Let's now elaborate these return or discard reasons in more detail. We can list them according to the usual supply chain hierarchy, starting with manufacturing, going to distribution until the products reach the customer. Therefore, we differentiate between manufacturing returns, distribution returns, and customer returns. We define manufacturing returns as all those cases where components or products have to be recovered in the production phase. This occurs for a variety of reasons. Raw materials may be left over. Intermediate or final products may fail quality checks and have to be reworked, and products may be left over during production or byproducts may result from production. Raw material surplus and production leftovers represent the product not needed category, while quality control returns fit in the faulty category. Manufacturing returns include raw material surplus, quality control returns, and production leftovers byproducts. Distribution returns refers to all those returns that are initiated during the distribution phase. It refers to product recalls, commercial returns, stock adjustments, and functional returns. Product recalls are products recollected because of safety or health problems with the products, and the manufacturer or a supplier usually initiates them. Business-to-business commercial returns are all those returns where a retailer has a contractual option to return products to the supplier. This can refer to wrong damaged deliveries, to products with a too short remaining shelf life, or to unsold products that retailers or distributors return to the wholesaler or manufacturer. The latter include outdated products, like those products whose shelf life has been too long, pharmaceuticals and food, and may no longer be sold. Stock adjustments take place when an actor in the chain redistributes stocks, for instance between warehouses or shops. Finally, functional returns concern all the products which inherent function makes them going back and forward in the chain. An obvious example is the one of distribution carriers as pallets. Their function is to carry other products, and they can serve this purpose several times. Other examples are crates, containers, and packaging. Summarizing, distribution returns comprehend product recalls, business-to-business commercial returns, stock adjustments, and functional returns. The third group consists of customer returns, or those returns initiated once the product has at least reached the final customer. Again, there is a variety of reasons to return the products: business-to-consumer commercial returns, reimbursement guarantees, warranty returns, service returns, end-of-use returns, and end-of-life returns. The reasons have been listed more or less according to the life cycle of a product. Reimbursement guarantees give customers the opportunity to change their minds about purchasing, commonly shortly after having acquired the product, when their needs or expectations are not met. The list of underlying causes is long. For example, with respect to clothes, dissatisfaction may be due to size, color, fabric's properties, and so forth. Independent of the underlying causes, when a customer returns a new product benefiting from a money-back guarantee or an equivalent, we are in the presence of business-to-consumer commercial returns. The next two reasons, warranty and service returns, refer mostly to an incorrect functioning of the product during use or to a service that is associated with the product and from which the customer can benefit. Initially, customers benefiting from a warranty can return products that do not seem to meet the promised quality standards. Sometimes these returns can be repaired, or a customer gets a new product or his/her money back, upon which the returned product needs recovery. After the warranty period has expired, customers can still benefit from maintenance or repair services, but they no longer have a right to get a substitute product for free. Products can be repaired at customer site or sent back for repair. In the former case, there are many returns in the form of spare parts in the service supply chain, since in advance it is hard to know precisely which parts are needed for the repair. End-of-use returns refer to those situations where the user has a return opportunity at a certain life stage of the product. This refers to leasing cases and returnable containers like bottles, but also returns to second-hand markets as the one for used books. Finally, end-of-life returns refer to those returns where the product is at the end of their economic or physical life as it is. They are either returned to the original equipment manufacturers because of legal product take-back obligations, or other companies, like brokers, take them for value-added recovery. Now let's continue with the reverse logistics framework. How or reverse logistics processes? The how viewpoint is meant to abord how reverse logistics works in practice. How is value recovered from products? Recovery is actually only one of the activities involved in the whole reverse logistics process. First, there is collection. Next, there is the combined inspection, selection, sorting process. Thirdly, there is recovery, which may be direct or it may involve a form of reprocessing. And finally, there is redistribution. Collection refers to bringing the products from the customer to a point of recovery. At this point, the products are inspected, their quality is assessed, and a decision is made on the type of recovery. Products can then be sorted and routed according to the recovery that follows. If the quality is close to as good as new, products can be fed in the market almost immediately through reuse, resale, and redistribution. If not, another type of recovery may be involved, but now demanding more action, a form of reprocessing. Reprocessing can occur at different levels: product level repair, module level refurbishing, component level manufacturing, selective part level retrieval, material level recycling, energy level incineration. At module level, the product, for example a large installation, building or other civil object, gets upgraded, refurbishment. In case of component recovery, products are dismantled and used, and new parts can be used either in the manufacturing of the same products or of different products remanufacturing. In material recovery, products are grinded and their materials are sorted out and grouped according to a quality wish. So recycled materials can be input raw material such as paper, pulp, and glass. Finally, in energy recovery, products are burned and the released energy is captured, incineration. If none of these recovery processes occur, products are likely to go to landfill. This figure here represents recovery options ordered as for the level of reprocess required, in a form of an inverted pyramid. At the top of the pyramid, we have the global levels, such as product and module, and at the bottom more specific levels like materials and energy. Please note that returns in any stage of the supply chain, manufacturing, distribution, and customer, can be recovered according to options both from the top and from the bottom of the pyramid. What types and characteristics of returns products? A third viewpoint on reverse logistics can be obtained by considering what is actually being discarded or returned. Three product characteristics seem to be relevant: composition, deterioration, and use pattern. Let's examine each one of them. Composition. Product composition in terms of the number of components and of materials is one of the many aspects to keep in mind while designing products for recovery. Not only the number but also how the materials and components are put together will affect the easiness of reprocessing them and therefore the economics of reverse logistics activities. The presence of hazardous materials is also of prime relevance as it demands special treatment. The material heterogeneity of the product can play a role in recovery, where one tries to obtain separate streams of different materials, which are as pure as possible, a problem in case of plastics. The size of the product has also been pointed out as a significant factor for recovery systems. One can mind the impact of this aspect on transportation and handling. Summing up, the intrinsic characteristics of a product are decisive for the recovery, since they affect the economics of the whole process. Next, there are deterioration characteristics, which eventually cause a non-functioning of the product, but also determine whether there is enough functionality left to make a further use of the product, either as a whole or as parts. This strongly affects the recovery option. Several questions have to be asked in order to evaluate the recovery potential of a product. Does the product age during use? Intrinsic deterioration. Do all parts age equally or not? Homogeneity of deterioration. And does the value of the product decline fast? Economic deterioration. In fact, products may become obsolete because their functionality becomes outdated due to the introduction of new products in the market, as happens with computers. This will restrict the recovery options that are viable. The same can be said for the intrinsic deterioration and whether or not it is homogeneous. If a product is consumed totally during use, such as gasoline, or if it ages fast like a battery, or if some parts are very sensitive to deterioration, reuse of the product as such is out of the question. If, however, only a part of the product deteriorates, then other recovery options like repair or part replacement or retrieval may be considered. The product use pattern with respect to location, intensity and duration of use is an important group of characteristics as it affects, for instance, the collection phase. It will make a difference whether the end user, as an individual or an institution, bulk use, demanding different locations for collection or different degrees of effort from the end user. The use can also be less or more intensive. Let us consider the case of leased medical equipment, which is commonly used for a small time period and it is likely to be leased again after proper operations like sterilization. Time is not the only component describing intensity of use, but also the degree of consumption during of use. Consider, for instance, the example of reading a book. Quite often one reads a book only once after the purchase and keeps it, but does not do anything with it later on. Who? Stakeholders involved in the recovery process. The management of reverse logistics requires some specific knowledge and skills. First of all, there is a need to understand what, the product, and who the actors are involved, the recovery processes, and the reasons or drivers behind the involvement of different actors. The following are the typical actors involved in the recovery processes. Retail companies primarily offer reverse logistics services to manage product returns, repairs, and warranties. Such services are often associated with the product warranties offered by original equipment manufacturers and may include the resale and redistribution of unsold products and product warranties. Some retail companies provide consumer packaging collection facilities voluntarily or following governmental requests. A significant quantity of recycled materials can be collected by retail companies during the distribution process. Similar to retail companies, original equipment manufacturers may offer services for product returns, repairs, and warranties. Manufacturers generally do not have stores, so they could own or outsource return centers to third-party logistics service providers or provide channels for consumers to return used products. Governmental agencies or local authorities normally offer waste collection and disposal services to households and shops. In many countries, most household waste is collected by government agencies or local authorities. However, the extent to which the reverse logistics systems facilitates reuse, recycle, recover, and disposal may vary greatly, depending on the collection and reprocessing systems provided. Private waste management companies and product return companies are third-party logistics service providers specializing in return management, acting on behalf of retail companies, original equipment manufacturers, and governmental agencies. These companies normally also sort materials and sometimes reprocess used products. In some countries, there are also individuals, scavengers, who collect reusable materials or products from rubbish sites. Traders are companies that purchase and sell recovered products or recycled materials collected by government agencies, retail companies, waste management companies, and scavengers. They play a significant role in aggregating and distributing recovered, recycled products to the reprocessors. Reprocessors are companies or individuals who disassemble, repair, remanufacture, refurbish, recycle, and reprocess products and materials from the disposal market and transform them into reusable forms. Unless the products are reused without the need of reprocessing, most recovered products need to go to reprocessors. These businesses have to be commercially viable and therefore require a constant supply of recovered, recycled products and materials, as well as a constant and profitable demand from the market. Customers are the last but the most important actors in the reverse logistics loop. They form the reuse markets. They may be consumers, commercial companies, or non-profit organizations. Charities are also major customers of recovered products, and there are companies that distribute and sell used spare parts or remanufacture products. Without demand from these actors, the reverse logistics systems will not be economically viable. Even though many actors are involved in waste management and reverse logistics activities, there is often a lack of efficiency and visibility. While providing reverse logistics services, many manufacturing and retail companies are more concerned about warranties and after-sales customer service than environmental sustainability. This is partly due to the lack of regulatory pressure and producer responsibility. However, in recent years, more commercial companies have established reverse logistics systems to recycle but also reuse, refurbish, and remanufacture. Product recovery activities can actually strengthen brand image. Driven by increased environmental awareness, many electronics manufacturers, for example, have transformed their product safety and occupational health organization units from a focus on purely regulatory compliance to a comprehensive environmental policy. Nowadays, most computer and mobile phone manufacturers offer attractive product recovery services, simply because customers only purchase new products from those who are capable of taking back used products responsibly. This viewpoint is made clear in this figure. The parties at the top of the picture are either responsible or made responsible by legislation. They are from the forward chain, like the original equipment manufacturers. Next, we also have parties organizing the reverse chain, which can be the same parties or foundations in case companies work together or even the state itself. Below these parties we have the two main reverse logistics activities, collecting and processing, which again can be done by different parties. The four perspectives of the reverse logistics framework not only give context to reverse logistics systems, but their combination determines to a large extent the kind of issues that arise in implementing, monitoring, and managing such a system. The precise influence of the four dimensions of the framework presented now, why, how, what, and who, is still an open question that requires more investigation. Reverse supply chain refers to the movement of goods from customer to vendor. This is the reverse of the traditional supply chain movement of goods from vendor to customer. Reverse logistics is the process of planning, implementing, and controlling the efficient and effective inbound flow and storage of secondary goods and related information for the purpose of recovering value or proper disposal. Typical examples of reverse supply chain include product returns and management of their disposition, remanufacturing and refurbishing activities, management and sale of surplus as well as returned equipment and machines from the hardware leasing business. In these cases, the resource goes at least one step back in the supply chain. For instance, products move from customer to distributor or manufacturer. Other instances of product reversing direction in the supply chain are manufacturing returns, commercial returns, business to business and business to consumer, product recalls, warranty returns, service returns, end of use returns, and end of life returns. Reverse supply chain processes. There are various types of reverse supply chains, and they arise at different stages of the product cycle. However, most return supply chains are organized to carry out 5 key processes. Product acquisition, obtaining the used product from the user by the reseller or manufacturer. Reverse logistics, transporting products to a facility for inspecting, sorting, and disposition. Inspection and disposition, assessing the condition of the return and making the most profitable decision for reuse. Remanufacturing or refurbishing, returning the product to its original specifications. And marketing, creating secondary markets for the recovered product. This figure here demonstrates a simplified schematic of a generic reverse supply chain for commercial product returns. The customer returns the products to the reseller, product acquisition, from where they are shipped to the returns evaluation location, reverse logistics, for issuing credit and product disposition, inspection and disposition. Diagnostic tests are performed to determine the commercially optimal disposal action for the returned product. There are various types of disposition actions, including remanufacturing if this is considered to be cost-effective. Some organizations simply treat all product returns as defective. There are returned products that may be new and never used, and these are returned to the forward distribution channel. Other products may be sold for scrap or recycling, usually after physically destroying the identity of the product. Remanufactured products are sold in secondary markets for additional revenue, often to a market segment unwilling or unable to purchase a new product. Another common use of returns is as spare parts for warranty claims to reduce the cost of providing these services to customers. In certain cases, legal requirements make it mandatory for product companies to take back their old and used products. For example, in the case of refrigerators in the US, companies are mandated to take back old products because of hazardous materials used in the manufacturing. In such a case, the reverse supply chain needs to be not only well managed but also tightly integrated into the delivery mechanism. Another example comes from Europe, where tire manufacturers need to recycle at least one old tire for every new tire they sell. In India, a common use of reverse supply chains is for promoting sales of new consumer products. Older products are collected, reconditioned, and resold at prices lower than the fresh products but much higher than scrap or salvage value. The importance of reverse supply chain is demonstrated through statistics originating in the US that suggest nearly 20% of everything that is sold is returned. This number obviously varies by product and channel type. Nevertheless, with the high ratio and challenging economic conditions, Addressing returns within the reverse supply chain can help cut costs, increase profit margins, or both. Now let's examine the different types of reverse supply chains. First one is centralized efficient reverse supply chain. This supply chain focuses on processing product returns at an overall lower cost. This supply chain model sacrifices speed over cost efficiency and is typically applicable to products with shorter time value depreciation. The cost efficiencies in the supply chain are obtained by centralizing the testing and evaluation of the returned product at a central facility, after which credit is issued. The retailer or reseller doesn't partake in any product evaluation at their end. Shipping costs are minimized by shipping the returns to the vendor in bulk. Once the product condition is determined at the testing facility, it is appropriately disposed. This model achieves economies of scale at each level, thus enabling minimization of processing costs. It is also easier on the retailer, which doesn't have to sort returns or ship them to multiple locations, as well as the third-party credit issuer, which has to issue credit at one time for multiple product returns. Next model is decentralized reverse supply chain with preponement. In the previous model, we saw that product differentiation is delayed until all returns are shipped to the central facility. This can be thought of as a postponement strategy. On the other hand, for products like personal computers, where the asset value loss over time is relatively high, we can prepone the testing and evaluation of the returned product using a decentralized model so that the unused products can be restocked immediately. This testing can be performed at the point of return by the reseller or retailer, but it would need to be technically feasible and it might require expertise development among resellers. Moreover, resellers would need to be incentivized through shared savings contracts with manufacturers, or vendors can set up a vendor-managed inventory process with larger retailers and maintain their own technicians to test the returned product. Environmental concerns. Increased regulations by US and European governments are causing manufacturers to invest in reverse logistics processes to ensure proper disposition of their products. Computer manufacturers such as Dell and Hewlett-Packard have received criticism for not properly disposing of the e-waste they generate. Landfilling practices are being overhauled due to stiffer disposal regulations, which have increased operating costs. Some companies are trying to apply internal research to establish environmentally friendly measures. However, the truth is that no company will implement processes that are not sustainable to them in the long run. If legislation forces them to do so, they will have to pass on the increased manufacturing costs to customers. Challenges persist across the manufacturing value chain for managing the reverse logistics processes. Here are the major challenges. Meeting consumer needs. Customers want the best price and completely flexible and hassle-free returns policies. Volume management. Retail returns are around $818 billion annually, and total returns across the US high-tech service industry are forecast at $1,625 billion through 2014. Especially during peak seasons, most of these returns are time sensitive to process and restock for resale. Management of costs. Expense management can represent up to 7 to 8% of the cost of goods. The process is labor intensive with very little automation. Data management. Having accurate data is important, but it is very difficult to obtain and manage relevant information. An organization should understand the data source, know how to analyze it, and should use third-party experts if possible. Disposition of product. Knowing the best location to handle, destroy, salvage, and even where to donate products is critical. So is the ability to handle a supplier return, whether it is defective or working with overstock balancing. Regulatory compliance. Organizations require complete understanding of waste management laws, regulations, and processes, including the company's corporate social responsibility. Partnership throughout the product lifecycle. Having the right partner throughout the product lifecycle is the key. Creating a strong and cohesive supplier agreement, jointly determining the best approach, cost sharing, and having a positive relationship will help improve the bottom line for everyone. Returns management includes all activities related to returns flow, reverse logistics, effective gatekeeping, and returns avoidance. Returns management addresses the systematic value-added approach to the entire backward flow of products from returns prevention through resale of product. This incorporates the steps for product rework to achieve a certifiable level of quality. Certifiable quality produces optimal resale values. Most organizations are highly focused on the forward supply chain. They have the metrics in place to keep everyone's attention on those forward revenue measures. In this instance, the cost of returns are considered too small to be of concern, or maybe the costs are buried in warranty costs. Typically, the costs for product returns are not well known or documented. The actual costs many times per action on returns management when they are made visible. There are a number of ways to deal with returns. First, do nothing. If you have no returns or returns are not a problem, then doing nothing may be acceptable. However, if you have troublesome returns, then doing nothing can add serious costs and reduce your bottom line. It can also begin to interfere with your forward logistics supply chain. By doing nothing, typically none of the product cost or lost revenue is recovered. Liquidate. Many large and small companies liquidate their product as is. Liquidation is generally thought of as the easiest and fastest solution for eliminating product returns. There are many troubles with this solution, including lost revenue, lack of control of your brand, and improper claims from end purchasers. Typically, liquidation results in a recovery of only 10 to 30% of product cost. Allows others the opportunity to resell product with your name on it with unknown quality, and could permit the reseller's customers an opportunity to return and repair these items under your warranty plan. Outlet overstock stores. This is similar to the liquidation strategy and is generally good for product that is obsolete, overstock, irregular, and refurbished. Low value recovery for the product is typical unless the seller owns the store. Typically, outlet overstock results are recovery of 10 to 50% of the product cost, provides others with an opportunity to resell product with your name on it with a known quality, and provides the reseller's customers an opportunity to return and repair these items under your warranty plan. Donate. The potential altruism of this can't cover the fact that the costs for doing this are very high. It is important to consult your tax advisor before proceeding with donations. There are situations where the donation can actually add cost to your business and the accepting party. Donations generally have no typical situations and are unique. The ability to donate is not infinite and requires more effort to dispose of these products without polluting your A market. Destroy write-off. This is the ultimate loss for product returns. However, it may be the right solution for some situations where the product has low value or channel conflict might occur. It is suggested that the product be destroyed and certified as destroyed, or you must be prepared to see it resurface from resellers on the internet and through other outlets. Typically, destroy write-off results in a negative product cost of -20 to -40%. Resell auctions. The ability to sell returns via auction is relatively new and has expanded rapidly. The upside is a greater percentage of recovered value from the returned product for refurbished returns with certified high quality. The downside is more work is required to sell the products using this avenue. However, this cost is generally recovered along with added profit. This option can have mixed results for as-is and open box product. Typical results from resale auctions can be: refurbished product usually recovers from 100% of product costs to 70% of retail. As-is and open box usually recovers 25 to 125% of product costs. You control the resale of a product with your name and reputation behind it, and you control unwarranted warranty costs. Private resale. This has been practiced primarily for overstocks or obsolete products. However, it is now being used for some product returns that have been refurbished or are of verifiable quality. Typical returns from this recoup up to 70% of retail price. So which of these is the right way to deal with your product returns? It depends on your needs, and we have some answers below for you. Making the right choice. Any of the choices described so far can be successfully applied individually or in combinations to your situation. Choosing the proper technique or techniques can be a challenge. The alternatives range from high cost and high management maintenance to profitable and low management maintenance. Making the right choice requires the ability to define the expected outcome, use the correct technique or combinations of the techniques and tools for each situation, and then deliver the results as planned using the resources you have available. Spending minimal management attention with a profitable value realized is generally the preferred outcome. This can be achieved if outsourcing is included in the early stages of planning and implementation. Long term, the results may warrant moving these activities to an internal group using the appropriate tools and systems, or continue outsourcing these functions. Making sense of dollars from returns. Outsourcing can generate more value if the partner selected has strategic value and can implement processes that fit your business needs. This involves asking the right questions. The questions to ask a return service provider are not "how do you handle returns?" They are "how can you create a comprehensive returns management plan for our products that helps to reduce the number of returns that must be dealt with from our customers, transforms inherently negative customer experiences into a valuable strategic asset, and generates profits from returns that were previously a loss?" Viewed from that perspective, the approach to returns management involves multiple parties, processes, and applications. With such a high order of complexity, the first step to take is to conduct a reverse management process study. Begin with the supply chain process and consider all the pieces and costs that might play a part in the ultimate solution. There are a number of fundamental areas that should be looked at to determine what returns cost the business today. In addition to supply chain costs, warehousing, transportation, and distribution, they also include customer service, marketing, sales, planning, and warranty support. The complexity of the returns process is not simply the physical return flow of products, but includes the interactions within the business arena needed to manage and properly account for the returned products. Returns management opportunities can be further impacted by visibly managing the conflicts that arise due to differing departmental goals and priorities. Third-party suppliers can be enlisted in this effort. For example, carriers and 3PL providers can provide visibility to the returns channel when the company cannot. In this and following lecture, we are going to examine the reverse logistics and recycling options. Reverse logistics is about the movement of goods from a consumer to a producer in a channel of distribution. Reverse logistics is almost synonymous with material recycling and waste management in efforts to minimize cost, retrieve value from reverse flows, and to fulfill legislative and environmental requirements. Reverse logistics is a broader concept for overall supply chain optimization, which aims to support closed-loop supply chains by affecting activities like product design, supply chain design, and product recovery. Reverse logistics plays the role of logistics in product returns, source reduction, reuse of materials, material substitution, waste disposal, recycling, refurbishing, repair, and remanufacturing. From a process management point of view, reverse logistics is defined as the process of planning, implementing, and controlling the efficient flow of materials in process inventory, finished goods, and related information from the point of consumption to the point of origin for the purpose of recapturing value or proper disposal. Hierarchy of waste management. Reverse logistics is an important concept both for companies that organize recycling and for those that have to pay for disposal or rundown or waste products. It is sometimes considered the backbone of sustainable development in its economic and environmental impact on business practices. It is considered an instrument of sustainable development and a driving force in sustaining the economy and environment. Reverse logistics is a crucial element of a closed-loop supply chain. Closed-loop supply chains are the typical forward flows of materials from suppliers and to end customers, and the reverse flows of products post-consumption back to the manufacturing or distribution supply chains. Reverse logistics prevents the disposal of end-of-life products in less environmentally friendly channels such as landfill and incineration. The level of environmental friendliness can be determined from the following hierarchy of waste management: reduce, reuse, recycle, recovery, and disposal. Reduce is the most environmentally friendly option. This may involve the use of less hazardous material and energy. Cleaner production can help to reduce energy usage. Industrial production can be modified to reduce hazardous waste and other materials. This method is also called source reduction. It involves changes in manufacturing technology, raw material inputs, and product formulation. Consumer behavior can also contribute to reductions. The fewer natural resources we consume, the less waste is created. Reuse involves the use of some parts of a used product or even the entire used product if it is repaired or remanufactured. Reuse can be considered a direct recovery option. Reverse logistics systems such as waste exchange, car boot or garage sales, and second-hand sales that facilitate reuse can help to reduce landfill. Recycle helps to separate waste into materials that may be incorporated into new products. Usually, recycling consumes energy in changing the physical properties of the material. It is a recovery option that requires reprocessing. Activities such as composting and the reprocessing of used empty beverage containers or packaging materials are examples. Recovery normally means the process of creating energy in the form of electricity or heat from the incineration of waste such as organic materials. Alternatively, it is called waste to energy or energy from waste. Disposal or a landfill is the last option. The problem with this option is that some materials will not be easily degradable and some of them contain toxic substances. Let's examine some product recovery options. Based on a detailed understanding of their products, companies can learn to manage the recovery and distribution of end-of-life products, planning of production and inventory, and supply chain issues in reverse logistics. Recovered products can be civil objects, consumer goods, industrial goods, minerals and chemical compounds, raw materials, distribution items, and spare parts. Next is understanding suitable product recovery options for each type. Product recovery management involves the management of all used and discarded products, components, and materials that fall under the responsibility of a manufacturing company. Product recovery management aims to recover as much of the economic and ecological value as reasonably possible, thereby reducing the ultimate quantities of waste. Due to a belief that the cost of product recovery management should not outweigh its benefits, most manufacturers focus on the forward logistics flow from the factories to the end customer rather than the reverse flow of the used products. Therefore, the traditional approach of many manufacturers towards used products has been to ignore them or let other parties dispose them. In the recent years, manufacturers have been pressurized by both consumers and governments to reduce waste generated by their products. In general, there are 5 major product recovery options. First one is repair. Its aim is to return used products to working order. The quality of the repaired products is usually lower than the quality of new products. Repair can be performed at the retail stores or repair centers. Products such as computers, mobile phones, and washing machines are suitable for repair. The aim of refurbishing is to bring used products up to a specified quality. Refurbishing involves disassembly of used products into modules, inspection of the modules, and fixing or replacing as required, then reassembly into refurbished products. The quality of refurbished products is often lower than those of new products. Products such as houses and caravans can be refurbished. Remanufacturing. The aim of remanufacturing is to bring used products up to quality standards that are as good as those for new products. The processes involved are similar to those of refurbishing. Used products are often completely disassembled into modules and parts. There is extensively inspection of modules. Worn out parts or modules are replaced, repairable parts are fixed and extensively tested, and approved parts and modules are reassembled into remanufactured products. It can be used for products such as copiers, engines, car parts, and machine tools. Cannibalization. The aim here is to recover a limited set of reusable parts from used products or components. Only a small proportion of the parts are recovered for reuse, remanufacture, repair other products and components. It involves selective disassembly and inspection of potentially reusable parts. The remaining parts are recycled or disposed of. Recycling. The aim is to reuse materials from used products or components. The recovered materials are separated into categories. The materials then can be used to produce original products and components if their quality is high, or can be used to make other products. Examples include milk bottles and soft drink bottles. There are some main differences between these recovery options. In terms of disassembly, used products are disassembled at product level for repair, module level for refurbishment, part level for remanufacturing cannibalization, and material level for recycling. The quality of remanufactured products is the highest as new, while the quality for repaired and refurbished will be lower. For repair, some parts are fixed or replaced by spares. For refurbishing, some models are repaired or replaced, and potentially there is a need for upgrade. For remanufacturing, used and new models or parts are combined into new products with some potential upgrade. Cannibalization is quite different. It reuses some parts and the remaining product is recycled or disposed of. Recycling works at the material level. That means parts are reprocessed to raw material forms. When choosing suitable product recovery options, several factors need to be considered. First, not all used products are technically suitable for reuse, repair, and manufacture recycling. For example, food packaging may not be suitable for reuse, but it may be recycled. Second, there is a need to investigate if there is a constant supply of suitable used products and components. This depends on the efficiency of the product return logistics flow, the willingness of consumers to return used products, as well as the quality of the returned product. Sometimes participation in product return can be motivated by monetary incentives and regulation, as well as the ease of participation, the latter depending on the design of collection schemes. The design of collection schemes and the location of collection centers determine the magnitude of return flows. The quality of returned products depends greatly on the design of the products and components, as well as the incentives given to customers to maintain the products while they are in use. Third, there is a need to ensure that there is a constant demand for reprocessed products, components, and materials. A better option is to reroute the recovered products to the forward logistics flows for reuse. The final consideration is economic and environmental cost and benefits. The value of the products, parts, and materials indicate if there is an economic value in setting up or investing in product return management. Since most reverse logistics systems contain many actors with a fragmented structure and lack of supply chain leadership, the efficiency of the systems are often constrained by the least profitable parts of the chain. It is therefore important to understand the costs and benefits of each actor in the entire reverse logistics system. To understand the economic value of product recovery management, a new concept called value recovery was introduced in 2008. Collection, inspection, sorting, reprocessing, and logistics and distribution network design are four important functional aspects in value recovery. The dimensions used to characterize the value are returns volume, returns timing, returns quality, product complexity, testing and evaluation complexity, and remanufacturing complexity. Value recovery strategies and programs can result in increased revenues, lower costs, improved profitability, and enhanced levels of customer service, leading to better corporate image. Let's continue with recycling. Not all products can be reused, refurbished, and remanufactured. However, their materials can be recycled and recovered for energy. It is possible to design a product recovery system to extend the life of a product or material, and here recycling plays a major role. Recycling is a big business. To illustrate how a recycling network works, let's first examine metal recycling. Virtually all metals can be recycled into high-quality new metal. Scrap metals can be primarily recycled from packaging materials, vehicles, electrical and electronic products, batteries, and so forth. Metal recycling companies carry out a range of functions, often including several of the following activities, with smaller operators supplying partially or fully processed metals to larger operators and traders. Collection, weighing, sorting, and distribution of metals. Shearing is required to reduce the size of large pieces of metal by cutting. Baling, compacting to improve ease of handling and transportation. Shredding of recycled materials to reduce feedstock to fist-sized lumps. Magnetic separation to further separate any remaining non-ferrous metals. Melting is the final process, which aims to return the recycled materials into their various metal components. In theory, all metals can be recycled. Lead, zinc, copper, aluminum, and steel are the most commonly recycled metals. In addition to the cost of collection and separation, the economic viability of recycling metal relies on the energy saved by reprocessing a kilogram of recycled metal, compared to the energy used to produce the same amount of metal from ores. Plastics are another important material for recycling. The use of plastics, as opposed to papers and other materials, has always been controversial. Should supermarkets ask customers to use plastic or paper bags? As far as packaging is concerned, the use of plastics is indeed more environmental friendly than paper. According to Science World, the production of every ton of paper bags consumes 4 times more energy than the production of plastic bags. The production of paper bags produces more air and waterborne pollution than the production of plastic bags. And furthermore, the recycling of paper consumes 85 times more energy than the recycling of plastic bags. Packaging using plastics contributes to about 63% of the end-of-life quantity of wastages for products such as processed food, vegetables, and fruit. The use of plastics has increased because they are durable, strong, resist corrosion, and above all require low maintenance. Plastics are used for making packaging materials in building and construction, electrical and electronics, automotive, and many other products. Plastic waste can be recycled by two major processes: mechanical recycling and feedstock recycling. Mechanical recycling involves melting, shredding, or granulation of plastic waste. Feedstock recycling breaks down polymers into their constituent monomers, which in turn can be used again in refineries or petrochemical and chemical production. The effectiveness of reverse logistics and recycling systems depends partly on the regulations. The European Commission has been instrumental in setting up regulations driving the reverse and recycling movements in Europe. For packaging materials, European Union Directive 94/62 on packaging and packaging waste set targets for member states to collect 60% of glass, paper and board, 50% of metals, 22.5% of plastic, and 15% of wood by 2008. In addition to recycling, the incineration of waste for energy recovery is regarded as contributing to the realization of these objectives. Directive 2008-98 in 2008 further increased the targets. By 2020, preparing for reuse and the recycling of waste materials such as paper, metal, plastic, and glass from households and possibly from other origins similar to waste from households is to be increased to a minimum of 50% overall by weight. Both European Union directives on packaging waste and landfill are putting immense pressure on local authorities and government. In June 2008, a compromise agreement was reached between the Council of Environment Ministers and the European Parliament on revisions to the Waste Framework Directive. The main changes include European Union-wide targets for reuse and recycling to 50% of household waste by 2020 and for reuse, recycling and recovery of 70% of construction and demolition waste by 2020. There is also a requirement for separate collection of paper, glass, metals and plastic by 2015 where there is technically, environmentally and economically practicable. A new waste framework directive establishing a binding 5-step waste hierarchy was implemented in 2008, bringing waste prevention, recycling and other recovery to the fore with a view to achieving higher resource efficiency. Increasingly, commercial companies or producers are expected to become responsible for the life cycle impacts of their products. In the past, producers were only required to provide information about methods to recycle their products to the wholesalers and distributors under the scheme called Collective Producer Responsibility. Some original equipment manufacturers have already established voluntary product recovery schemes ahead of the new regulation. The new extended producer responsibility programs typically hold the producer, a single actor defined by the regulator responsible for the environmental impacts of end-of-life products. Producers will be required to provide and pay for take-back schemes for their products, the take-back obligation. This has started to put more responsibility onto producers. The typical processes addressing reverse logistics and closed-loop supply chains can be readily classified depending on the characteristics of the manufacturers and sellers, the buyers, the distribution channels used, the use of third and fourth-party logistics providers, the degree of interest, and the value of the material in the process. There are 4 models that currently exist. Basic reverse logistics model. The basic reverse logistic business model simply deals with the return of unwanted materials and products to a central location for processing and disposal. It operates independently of the direct supply chain which originally delivered it. This basic model describes the activities of the traditional waste and junk dealer or service organization. In this model, which can be run as a business or as a governmental service, usually at the city, municipality, or local level, the emphasis is on the economic disposal of waste or trash through land or sea dumping or recycling. Closed-loop supply chain involving integrated direct and reverse logistics repair service cycle for high-tech products. In this business model, generally found in a high-tech product environment, the original equipment manufacturer supports its own product line sold to its customers in the field and takes responsibility directly for the reverse logistics process. The products, as well as any subassemblies, parts and components that are in the field after delivery, are returned and recovered by an original equipment manufacturer through indirect channels representing the OEM or the OEM's own field inventories. The primary differentiator is that in this model the entire direct and reverse logistics flow can be and usually is controlled by the original equipment manufacturer. The reverse logistics flow to depot repair will either put the material back into inventory for resupply directly to the field or into a qualification and reconfiguration process, which leads to either reuse at the manufacturing level or full disposal into secondary markets. The third model is closed-loop supply chain involving independent direct and reverse logistics repair service cycle for standard to low-tech products. In this business model, the end user or purchaser uses its own internal plant and building maintenance service force or its own supply chain processes rather than relying on the outside original equipment manufacturers or indirect dealer channels. In this model, the buyer or user is typically a large organization with a number of smaller dealers or original equipment manufacturers supporting it. In this situation, the buyer tends to pick up more of the responsibility for reverse logistics or repair, using its own forces or third-party logistics organizations. In essence, this process looks very similar to the high-tech process discussed, except for the issue of who is specifically responsible for which actions. In this model, the direct and reverse logistics supply chains are independent of each other. The original equipment manufacturer does not control the full process. The fourth model, consumer-oriented closed-loop supply chain. This business model is typically found in the consumer market. In this business model, the primary interaction is between the retailer and the original equipment manufacturer. Some of the returns from the purchaser back to the retailer are failed units or products that were simply purchased and returned. A portion of returns are unsold products returned to clear the retailer's shelves or products returned by the retailer's customers. This process is also very typical of the consumer goods and material recall process. In this model, there are two reverse logistics linkages: consumer to retail and retailer to original equipment manufacturer. Real differences exist in the reverse logistics and closed-loop supply chains processes under the different business models. In the pure independent reverse logistic process, Model 1, the process starts with the end user or purchaser's decisions that the product is at the end of its life for the purposes of the original buyer and needs to dispose of the material. The whole reverse logistics process is carried out independently of the direct supply chain. As indicated, pickup and collection for residential consumers is usually done by local government agencies directly or under subcontracts. Hazardous materials are usually picked up separately and processed and disposed based upon specific green load type regulations. Other materials after pickup and collection are then sorted and assessed, leading to recycling and processing and sold for the value of the recycled materials or sent for final disposal. This is a relatively simple business that is carried out by a government services organization or by an independent business organization and is compensated by local government contracts by providing the pickup and collection service and through the value generated from recycling or processing of the trash and waste into materials that can be sold to third parties. The more complex reverse logistic processes, the next three models typically introduce the concept of a closed-loop supply chain, which is management handling both the direct supply to the end user and the reverse supply chain from the end user. While the processes may seem similar, definite differences exist in the process flows. In the typical high-tech closed-loop supply chain, in which the manufacturer also provides its distribution and field service and support capabilities, a true closed-loop process is at work. The material flows out from the manufacturer through warehouses and inventory to organizations owned or contracted by the manufacturer for installation. In these high-tech situation, products are generally treated and tracked by serial number or at least by type as part of the initial installation. Continuing service and support of the equipment under warranty, extended warranty, or after warranty support on a service contract or time and materials basis is usually done by a field service organization as part of the original equipment manufacturer or under direct contract to the original equipment manufacturer. Thus, the return flows are also tracked and controlled by the same organization that supported the direct forward supply chain operations. As noted in Model 2, returns from the field under a closed-loop supply chain process can generally result in parts and material immediately sent back into the field inventory or returned for full qualification and subsequent reuse. In the manufacturing operations or sales organization, or for final disposal to secondary markets, or to trash or recycling organizations using the process outlined in Model 1. The alternative closed-loop supply chain process, the third model, occurs in situations in which the manufacturer does not also control the installation, field service and support directly to the end user. In many markets, the end user operates its own internal plant and building maintenance service forces, which take the responsibility for delivery from the manufacturer, dealer or distributor and provide service for the equipment. These organizations normally acquire both the whole unit and appropriate parts and subassemblies in order to support the unit over its life cycle. Another option is for the end user to make use of a third-party service provider rather than its own internal service force. The final business model 4 involves reverse logistics operation in a consumer goods environment. This represents a further modification of the alternative high-tech closed-loop supply chain Model 3, in that a full separation exists between the manufacturer and the end user through separate and independent retailer or distributor organizations, which may or may not supply full service and support. The existence of the separate and independent retailer not only creates increasing problems for the control of the entire logistics support pipeline, but also introduces other important dynamic factors. In the first place, under the processes outlined in Model 2 and 3, the primary return dynamics are generated from the perspective of the end user's experience and use of the products. In the consumer goods business model, Model 4, the retailer may also be returning material and goods independently of the end user's purchases, due to the distribution or retailer requirements to clear shelves, obsolescence, and recalls. In broad terms, the return rates to the manufacturer in a consumer goods closed-loop supply chain is internally much higher than in the supply chain situations outlined in Model 2 and 3. Products versus parts returns. The process descriptions we just outlined also can vary as a function of the type of material in the closed loop or reverse logistics pipeline. The difference in flow can be observed more clearly in several terms. Parts and subassemblies. The return of parts and subassemblies generated by field level pull and replace or module repair by technicians lead very well to closed-loop supply chain management and control. This process is usually found in high-tech markets in which the parts and subassemblies are continuously reused after repair and processing in the field. Consumables and materials. These include chemicals, paper, glass, and other consumables that cannot be reused directly but must be recycled and fully processed before they can be reused in the manufacturing process as material input or sold to third parties. Whole unit equipment and products. Whole unit returns usually include technology coming off lease or trade-ins on new product sales, obsolete products, or whole units requiring major repair that cannot be done in the field. These products can be returned through the primary supply chain as part of a closed-loop system or sold into secondary markets. Strategic issues in closed-loop supply chains. A new concept is that closed-loop supply chains have become a strategic issue, particularly for global manufacturers that serve multiple markets, including those that require product technology on the cutting edge, as well as other markets into which less advanced technology can be sold. The concept also has great strategic value for organizations involved in service and support of either their own products and technology or other manufacturers' products and technology in situations in which product sales revenue growth is stagnated and product margins are eroded. In these situations in particular, a customer asset management strategy focusing on generating revenues and profitability from the service and support of the customer base can create a major turnaround. In essence, the closed-loop supply chain process introduces a differentiated service offering to an existing customer base, in which service sales are used to grow revenues and increase profitability through expanding the full service offering of the firm to provide comprehensive customer support. In essence, the strategic value of closed-loop supply chains and reverse logistics management operations will have a very positive effect in terms of reducing cost of returns, increasing the value of the salvage merchandise, capturing vital information and reliability, maintainability and dependability of products supported, reducing transportation and warehousing expenses and time, including the partial or full elimination of small package shipments, automate and fully control the total returns process. General experience dictates that the introduction of closed-loop supply chain management can result in the bottom line direct savings of 1 to 3% or more of total revenues, particularly for organizations in a mature or stagnating market as well as those that have elected to move to customer service-oriented business strategy. These strategic values are accomplished through the primary goals of closed-loop supply chain reverse logistics strategies, which include the maximization of inventory value through rapid returns to the manufacturers for reuse, ability to liquidate products, parts, and subassemblies with value in secondary markets, controlled recycling or disposition within environmental and other legal requirements, ability to efficiently process returns back into the original direct supply chain. In addition to these overall impacts, the full implementation of closed-loop supply chains has the major advantage of pushing the resolution of the returns upstream through centralization and overall control of the full returns process. By centralizing the management of the returns process decisions with respect to repair, refurbishment, disposition, and secondary market, sales can be made more efficiently. This reduces transportation and time costs through multiple touchpoints and eliminates long cycle times in resupply, thus reducing the levels of service inventory investment requirements. Return cycle times under a typical reverse logistic process as compared to a high-tech closed-loop supply system demonstrate the real operational value in terms of reduced time and cost of moving to a full closed-loop supply chain system.